It's Math Doctor.
Hey guys, welcome to all of you. This is Math Doctor, and today we are going to discuss about number systems, and which we have already discussed in the previous lecture, binary into decimal system. And today we are going to discuss pending two systems, and two have we have already discussed. So there are four systems in number systems which we are discussed in this series, and let's begin with hexagonal to octal system. So for converting any types of system, either hexagonal to decimal, either hexagonal to octal, except binary, we have to go through one particular path, which is first convert into any types of system, like for example decimal to binary. If it is binary, then directly convert it to any type of system, either hexagonal or octagonal. So for example, we are converting it to octal to decimal, we first have to go through binary. So binary is the base unit of every system. So for converting of any types of system, this is going to be path of us in first step, and second step is going to be convert that system into octal or either hexagonal system. So let's discuss about this is going to be very helpful for you in your PPS and programming for problem solving, and there are a lot of which you given in electronics which hexagonal systems are used, and many things are in computers, how compilers exactly. If you're going to work on compilers, you are going to learn binary system. So this is going to be base of any system. Binary system, which we have discussed only 0 1 and 0 1, and we have discussed in decimals we are using only 0 to 9. So here why in it here we have introduced the concept of hexadecimal and octal system. Let's learn about it, and why there is subscript 16, and there are 16 numbers total. We are going to see 0 to 9 and from A to E. So these are 6 numbers and these are 10 numbers, 10 plus 6. And so here we are going to use 8 numbers which are 0 to 7. So let's discuss the basic concept of binary converting binary into octal first. So for converting binary to octal, so we are going to use 1 1 1 first case. This is going to be least set of binary which we are going to take. For example, we have given 1 0 1 and 1 and again 1. So we are going to make three pairs. Okay, 3 pairs here, and we use 0 here for our convenience. So this is how we convert binary into octal. So we used only this, we have given this whole binary, then we convert it into octal system. We are going to first of all take its parts. Okay, so three parts. Why we take it 3 parts, we are also going to discuss it. So for instance, we are going to take, this is already in 3 pairs, so we are directly write it into 1, and this is going to be 2 raised to power 2, this is going to be 4, this is going to be 2, this is going to be 1, and this is going to be 7. So can you imagine now why we have used three pairs? Because when we use 4 pairs, the maximum of 4 pairs is 15. So which is not going to be in writing a convenience for us. And in here we are also take not 15, 0 to 9, where we are denoting it in hexadecimal 0 1 6, and for 10 we are going to use A, and for 11 we are going to use B. And so if we write that, so how can we say that this is 0 1 and 6 1 1? So this is not going to be, not going to be pair. So we are going to write here 0, 1, 6 and B. So this is the right thing. So why we introduce these facts? So let's discuss first convert into binary system. This whole into binary system. This is B is, let's discuss it. B is 11. So 11 we convert into binary systems. How we convert it into binary system? 11 is 8 plus 2 plus 1. So as we have already discussed in the previous lecture, 8 plus 2 plus 1 is 8. Why we split into 8 plus 2 into 1? Because we want only that power of 2, that number which are the any power of 2, which are divisible by 2 many times. Okay, like 2 raised to power x for any value of x. So we are going to take that number. We are going to split any particular number into that number. So here we have discussed that why we take 0 to 7, because 0 to 7, and if we are going to take 0 to 7 in this octal systems, and then we convert, then we take 3 pairs. So maximum of 3 pairs, what is not any 2-digit number. So we are not take value 11 or 12. So we have maximum take the value in octal system is 7. This is going to be not 7. This is going to be 5, and this is going to be 2. Okay, so this is going to be 2, 5. So that's how we introduce the system of octal decimals, and let's discuss how a hexagonal system exactly works. So we have discussed A denotes 10, B denotes 11, and similarly C denotes 12. So these are the 16 digits. Let's take an example of hexagonal system to octagonal system. Let's convert first of all these systems. So let's take an example, 108. Okay. Let's take another example, 1 A, B, C, and 1. Okay. So A1, B. So we are going to convert first of all it into binary. Then what is A? A is 10. What we write to 10? 10 we write into how many decimals? So 0 is 0, 8 is simply 1, 0, and again 0 and again 0. So this is going to be 8, and this is going to be 8 plus 2. 10 is 8 plus 2, because we have already discussed that how we convert this decimal system. This is in decimal, it is 10. A is 10. Hexadecimal A denotes A equals to 10. So we convert into split into that numbers which are like which are the power of 2. Any power of 2 gives us that number. 2 raised to power 3 is 8, 2 raised to power 4 is 16, and 2 raised to power 1 is 2. So we split that number A 10 into that numbers which are exactly the power of 10, power of 2, which are exactly divisible by 2 many times. So only divisible by 2. So that's how we split. This is 8 plus 2. This is 8. 8 denotes 1, 0, 0, 0, and 2 denotes 1, 0, and 0 denotes just 0, and this is not 1, 0, 0, 0. So this is the binary which we have taken. Okay. This is the binary which we have convert from hexagonal to for converting for hexagonal to octal. So then we use this binary for converting into octal. So for either you go from octal to decimal, you have to first of all convert into binary, then go. So for taking hexagonal to octal, we are going to discuss. We are going to take only 3 pairs as we have discussed already. So we have here we have converting decimal to octal. Here we are converting hexagonal to octal. So we must have to, in binary system, we must have to take 3 pairs, because 3 pairs maximum it does not exceed 7. So this is the system we use 0 to 7, and that's why we paired it. That's how we paired it. So this is going to be again 0 because here only 1 0. Then we take 0 because it's no value. It has no value here, 0. So in front of the whole binary digit. So here we are going to part this and convert the whole into decimal form. Then how we get that octal system, because octal system defines that 0 to 7 we take only 0 to 7 digits. So that's how we convert 0 into 0 0 0 is exactly 0, and this is going to be 1 0 0 1. This is again going to be 1. This is again going to be 2. So this is the octal system that we have converted from 108 to 2110. And let's take an example of this also. Here 10 and 1. Again for B we have taken this is going to be binary now. So 10 1 11. Okay. So these are not binaries. We have converted to binaries. These are the numbers in decimal form. A denotes 10. Okay, so let's convert it to binary. Binary is 8 plus 2. 8 plus 2, 1. Only 1 because 2 raised to power 0 is 1. We know that. So we have to split into that numbers which are only divisible by 2. Only and only divisible by 2. Many times. So 11 is again 8 plus 2 plus 1. So this is going to be 1, this is going to be 1 0 0 0, and again 1 0, and again 1 is exactly 1. So 8 plus 2 plus 1, 1 0 0 0, and 2 is 1 0 1. So this is going to be our binary, and let's convert into 3 3, make 3 3 parts of it. 1 0 1 is nothing but 5, and 0 0 0 is 0 0 0 is 0, and so 0 1 1, and again take 0 here. So 0 1 1 is exactly 3. So here 0 0 1 is 1, and 0 1 0 is 2. This is going to be our octal system. So here octal system we have only 0 to 7 digits. Okay, so 0 to 7 digits we used in octal system. That's why we have taken binary for 3 3 pairs, so that maximum is not going to be exceed any value of 9. So its maximum is 7. So we are taking only single digit for that. For instance, for to be going to be displayed to everybody else easily. So it makes sense that for example we are going to learn about octal to decimal, octal to hexadecimal, or either octal to decimals. So for example we have take 1 2 3 7, only because 7 there are only 7 to 7 we have used it. So for 1 we are going to first of all converting into 1 2. Here I will also going to introduce you that when we convert it into, so let's convert first of all 1 into binary, which is 1, 2 is 1 0, and 3 is 1 and 1. Okay, and 7 is 1 1 1. Okay, so this is going to be binary system. Now let us convert the whole into, we don't have to take now 3, because we are going to convert it to hexadecimal systems. So hexadecimal systems, we know that it is constrained to only 16 digits. So here we have the notion of 10. So we can exceed single digit number to 2 and 3 and 4. So let's discuss about how here we are f denotes the maximum, which is 15. How we can get maximum of it? So for getting maximum of taking parts of this binary system, how we get taking parts that we cannot exceed our hexadecimal systems, which is going to be 0 to 15. So we have 15 is the maximum. So we don't going to exceed 15 by taking parts of this binary, and we don't have to exceed 15. So let's discuss about taking parts of 4. So maximum of 4 is 1 1 1 1. It's not 1 0. If we introduce 0, then it will be lesser. This is a fact. So this is going to be happen. This is common thing. So let's take convert 1 1 1 into decimal form and write it in decimal into hexadecimal, which we have the notion of A to F. So this is 15. We know 1 plus 2 plus 4 plus 8 is going to be 15. 8 plus 4 plus 3 plus 2 plus 1 is going to be 15. So maximum of this is, that's why we have used hexadecimal system. For more hexadecimal system, so we will take 5, okay, which is nothing but 31 is the another type of system which we going to take part of this binary. So then we get that maximum. That's why we have used 16 here. That's why we have used 7 here. There may be other type of system which has numbers from like for example, this is 1 1 3. There are 4 numbers there, 0 to 3, and that should be also system. But we are taking these definitions of hexadecimal into 16 and octadecimal into 8 by constraint ourselves to make parts of this binary for converting. For converting octal to hexadecimal system, we are going to take part of this separating our binary into that parts, so that each part cannot exceed that 15. So that's why we have used 16 digits there. So 15 is the maximum, 0 to 15. So there are 16 digits. That's why we have used subscript here, 16. And in binary, we have take 2 subscript. And there may be other which have 4 subscripts. So which from binary is the smallest one, because 0 and 1. So this is going to be smallest. So 0 and 1 is 1 1, and which is 3. So the maximum is 3, but we are taking it into decimals. That's why we increased. We use it as a base for converting each and every type of system. So this is the smallest, 2 is the smallest. Okay, so let's look at how we convert this binary 0 1 1 0 1 1 1 1 1 into our hexadecimal. We know how to convert this binary into decimals. Decimal is easy. Decimal is actually 0 raised to power, because we don't take parts of it. We are not because we have not writing each and every part 2 and 5. We are taking it 25. It's not 82 and 5 in octal decimal system. So 25 in converting from binary to it. So for that hexadecimal system, we are take 4 parts. 4 parts, it is 15. 15 indicates what 15 indicates. We don't going to write 15 first of all. We're going to use its representation, its notation. This is 5. That is F. So for this we are 1 1 1 1 1 0. This is going to be D. This is going to be D, because it is 13. When we count, this is 13. 15 plus 2 minus 2 is 13. So D denotes 13, E denotes 14, and F denotes 15. So 0 and 0, again we are going to take parts by putting here 3 zeros, which is going to be 0. So 0DF is the final answer. So for converting this into decimal system, we know that how we convert it to 2 plus this is going to 15, this is going to be 31, and this is going to be 64, and this is going to be 128. Okay, so this is going to be 823 is in decimal. So we are not taking this decimal, but we used in computers, we use compilers, and C compiler, we have a lot of other applications which convert, like MinGW, which converts it that binary system into automatically into decimals, because computer only knows binary. So binary is the base unit we have also used in electronics, gadgets, and computers, and our mobile phones. So this indicates on and off in binary system. So we know that. So this is how going to be happen. So for converting any types of system, you are going to take binary, your first preference to convert that system into binary, then convert it to that particular system. For converting octal, you have to take binary parts, 3 pairs. Okay. For converting from any type of system into hexadecimal system, you have to convert binary into 4 parts. So this is going to be happen when we going to convert any types of decimals into binary, decimal into hexadecimal. This is again going to be happen in that case, because we use our material, which is raw material, which is binary. So for converting into any type of system, we use binary as our component, so as our ingredient. So we are going to be, this is base of any system for converting into. So that's how the definitions we have made 16 and 8. Why we take this 8, 0 to 7, you have already know, because we take binary of 3 parts, and that's maximum is, so it cannot exceed maximum of it. So we are in decimals, we are going to do 0 to 9 only, because we don't want to pronounce it 10, we don't pronounce it 10, we're going to pronounce it 10 in either octal, in either hexadecimals. So in hexadecimal we have already introduced our alphabets. So this is how going to be convert, so converting from binary to any system. So thank you to all of you. Please like, subscribe my channel, share it with your friends, and if you like, please comment. For any query, comment me please, I will surely reply to you. And that's the lecture of today. So thank you, I'll meet with you next lecture.